A kinetic interceptor costs $2 million. A commercial quadcopter, strapped with C4 explosive, costs barely $2,000. We are trading mansions for pennies. Let me repeat that. We are trading mansions for pennies. This is the absolute asymmetry of modern warfare. For 8 decades, American maritime dominance relied on a rigid, comforting assumption. We assumed adversaries would fight our way. We assumed they would deploy expensive, easily trackable assets. We prepared for supersonic cruise missiles and nuclear-powered submarines. We built billion-dollar shields to stop million-dollar swords. That era of symmetrical warfare is over. The modern threat does not show up on early warning radar. It flies under the deck. It is autonomous, low-flying, and entirely disposable. The threat is the drone swarm. Cartels, proxy militias, and near-peer adversaries now possess air forces built from commercial parts. They weaponize consumer technology. In late 2025, the Pentagon acknowledged this fatal vulnerability. Conventional air defense was bankrupting the military. They executed a rapid organizational shift. They established Joint Interagency Task Force 401. Their mandate is singular and absolute. Neutralize the small unmanned aerial system threat across all domains. To achieve this, JIATF 401 authorized hundreds of millions of dollars in accelerated procurement. They are bypassing traditional bureaucratic delays. They are prioritizing autonomous software paired with high-energy lasers. This includes integrating Anduril's Lattice network with systems like the Army Multi-Purpose High-Energy Laser. This is not a standard defense acquisition. This is a structural overhaul of naval and ground survival. Visualize a forward-deployed destroyer operating in the Red Sea. Its radar detects 50 incoming loitering munitions. The commander faces a brutal, impossible choice. Fire a limited payload of multi-million-dollar interceptors, or risk a catastrophic strike on a billion-dollar haul. The math is mathematically broken. The adversary knows it. They are bleeding our magazines dry. They force us to expend our most advanced interceptors on plastic and fiberglass. But JIATF 401 has introduced a new variable. They are stripping the adversary of their primary weapon, the cost advantage. The question is no longer if we can physically shoot down a drone. It is how we rewrite the physical laws of interception. To understand the $600 million solution, you must first decode the unforgiving math of the problem. Tactical doctrine is governed entirely by logistics. Strategy is theoretical. Logistics are absolute. The structural gap in our current defense matrix is fundamentally an economic failure. It is not a technological one. We possess the best radar. We possess the fastest missiles, but we are losing the war of attrition. Examine the Arleigh Burke-class guided missile destroyer. It is a masterpiece of maritime engineering. It is the backbone of the U.S. Navy's surface fleet. It displaces roughly 9,000 tons of water. It carries 96 vertical launch system cells. These VLS cells are the ship's primary teeth and its primary shield. They hold a mixture of Tomahawk land attack missiles, anti-submarine rockets, and standard missiles. If a hostile proxy launches a barrage of cheap one-way attack drones, the ship is forced to respond. Its Spy-1 phased array radar tracks the incoming threats. The Aegis combat system evaluates the trajectory. It allocates a standard Missile-2 interceptor to a slow, low-flying drone. The SM-2 costs $2.1 million. $2.1 million to destroy a commercial lawnmower engine wrapped in fiberglass. Let me repeat that. $2.1 million to destroy a commercial lawnmower engine wrapped in fiberglass. This is the mathematical equation the enemy relies upon. The cost of the drone multiplied by its quantity will always be less than the cost of the interceptor multiplied by the ship's magazine depth. The adversary does not need to sink the destroyer. They do not need to penetrate its armor. They only need to empty its VLS cells. A warship with empty tubes is tactically useless. It becomes a multi-billion-dollar liability floating in hostile waters. Once the VLS cells are empty, they cannot be reloaded at sea. The ship must break station. It must abandon its patrol sector. It must retreat to a friendly deep-water port. It requires a heavy crane, specialized munitions handling facilities, and secure logistics chains to reload. A 10-day transit back to Naval Base Guam or Yokosuka removes a critical asset from the operational chessboard. The enemy achieves localized sea denial without firing a single torpedo. They win by forcing us to leave. This mathematical attrition extends to terrestrial bases. U.S. Central Command and Northern Command rely on layered defense networks to protect critical infrastructure. But when a swarm of 50 drones approaches an installation, the defense degrades rapidly. Firing 50 Patriot PAC-3 or RAM interceptors instantly exhausts local stockpiles. Mass is cheap. Precision is finite. The enemy deploys mass. We deploy precision. This creates a critical, predictable window of vulnerability. The adversary utilizes the drone swarm as a vanguard. The drones are the bait. Once our kinetic magazines run dry, the installation is exposed. It is entirely defenseless against the secondary strike. The secondary strike consists of heavy, precision-guided ballistic or cruise missiles. We are spending our premium shields on cheap decoys. Joint Interagency Task Force 401 recognized that this kinetic interception model is mathematically unsustainable. For decades, the traditional military-industrial complex offered a simple, flawed solution: build more expensive missiles. JIATF 401 rejected this. They demanded a system with an infinitely deep magazine. They required a weapon architecture where the cost per kill is measured not in millions of taxpayer dollars, but in pennies of diesel fuel. They required directed energy. But more importantly, they required directed energy governed by autonomous artificial intelligence. The hardware alone could not solve the logistics trap. To decode the JIATF 401 intercept plan, we must compare the legacy architecture with the new standard. We are comparing finite kinetic energy with infinite directed energy. We are comparing human-in-the-loop targeting with autonomous sensor fusion. The legacy platform is the kinetic interceptor. Think of the RIM-116 rolling airframe missile or the SM-2. These systems rely on chemical solid rocket propulsion. They rely on physical collision or explosive fragmentation to destroy a target. They have a rigid, unyielding physical footprint. A missile occupies volume. A warship, a striker armored vehicle, or a static base can only carry a strict maximum number of tubes. The reaction time of a kinetic system is bottlenecked by mechanical reality. Launch doors must physically open. Solid propellant boosters must ignite. The projectile must travel through the atmosphere. It must fight gravity. It must correct for wind shear. It must bleed energy during high-G maneuvers. The new platform is the Army Multipurpose High-Energy Laser. It is integrated directly into Anduril's Lattice operating system. This system is fundamentally different. It is a 50 kilowatt class continuous wave laser. It does not fire a physical object. It fires concentrated photons. It engages targets at 186,000 miles per second, the speed of light. The specific mechanical feature that shatters the old tactical math is magazine depth. The AMP-HEL possesses no VLS cells. It lacks launch tubes. It requires no explosive handling protocols. Its magazine is the diesel generator spinning next to it. In a naval application, its magazine is the ship's electrical grid. As long as electrical power flows, the weapon fires. The cost per engagement plummets from $2.1 million to approximately $10. $10 per kill. Let me repeat that. $10 per kill. This eliminates the logistical tether. You do not need to sail back to Guam to reload electricity. But raw directed energy is useless without an infallible brain. Firing a 50 kilowatt beam is not like firing a shotgun. The beam must be held perfectly steady on a maneuvering target kilometers away. It must hold that exact position for several seconds to achieve a thermal kill. It must burn through carbon fiber shielding. It must ignite the drone's lithium-ion battery pack, or melt its flight controller. This demands superhuman micromillimeter precision. Human operators cannot track a maneuvering quadcopter with a laser manually. This is the core of the JIATF 401 strategic pivot. The hardware is useless without the software. They contracted Anduril to provide the digital nervous system. That software is Lattice. Lattice is an AI-enabled, open architecture command and control network. It is designed to be sensor agnostic. In a modern battle space, a base is surrounded by disparate sensors. You have passive radars. You have the Anduril Wisp infrared optics. You have acoustic arrays listening for motor whine. Traditionally, these sensors output data to separate screens, requiring human operators to cross-reference and build a mental picture. Lattice ingests all of it simultaneously. It aggregates the raw data. It fuses the radar returns and thermal signatures into a single, flawless optical track. Traditional radar struggles immensely with Group 3 drones. A commercial quadcopter possesses the radar cross-section of a small bird. It flies low, hiding in the ground clutter. A human operator staring at a radar scope cannot reliably distinguish a hostile drone from a flock of seagulls or localized weather anomalies. Lattice removes the human from the detection loop. Its neural networks are trained on millions of flight hours. It classifies the threat in milliseconds. It distinguishes the rotor wash of a drone from a bird's wings. It calculates the incoming trajectory, speed, and intercept vector instantly. More importantly, Lattice's computer vision pinpoints the exact structural vulnerability on the drone's airframe. It does not just aim for the center of mass, it aims for the payload or the power source. Once the threat is classified, Lattice assumes direct control of the laser's optical director. It slews the heavy gimbal to the target. It adjusts for atmospheric distortion. It compensates for humidity and thermal blooming in real time. It holds the beam perfectly on the motor housing, making micro-adjustments faster than human cognition allows. This doctrinal shift is absolute. It transitions military defense from a kinetic fire and forget model to a directed detect, illuminate, and eradicate model. The adversary's entire asymmetric swarm advantage is nullified. The mathematical equation that threatened to bankrupt the military is permanently inverted. The incoming swarm is finite, limited by the enemy's production rate. The laser's magazine is infinite, limited only by the laws of thermodynamics. We will now execute the wargame. We will observe the interlocking system in a simulated live fire scenario. This is not theoretical. This is the exact condition chain engineered by Joint Interagency Task Force 401. The environment is a strategic maritime choke point. A U.S. Navy carrier strike group is transiting a narrow, contested strait. To protect the transit, a forward operating base on the adjacent coastline provides an umbrella of air defense. It is 300 hours. The atmospheric conditions are hostile. High humidity, low visibility. The adversary executes the play. From concealed, mobile launch racks 50 miles inland, they deploy a swarm of 36 loitering munitions. These are Shaheed-style delta-wing drones. They utilize rocket-assisted takeoff before transitioning to cheap, two-stroke gasoline engines. They drop to an altitude of 100 feet, flying in a dispersed terrain masking formation. Their objective is to overwhelm the coastal base's Patriot batteries, leaving the carrier strike group vulnerable to heavier anti-ship cruise missiles. This engagement relies on a strict four-step condition chain. Every step is mathematically dependent on the absolute perfection of the previous step. Condition 1. The autonomous sensor handshake. At 40 miles out, the drones are beneath the radar horizon of standard early warning systems. The curvature of the Earth hides them. But the base is equipped with the Anduril Lattice network. The perimeter is lined with Wisp electro-optical and infrared sensors and Heimdal active electronically scanned array, or AESA, radars. A traditional radar operator would see nothing but ground clutter. The Heimdal radar emits thousands of micropulses per second. It detects faint, erratic returns. Simultaneously, the Wisp infrared sensors detect 36 microscopic heat signatures against the cold desert background. Condition 1 requires edge computing. The data is not sent to a remote server farm. It is processed on-site in milliseconds. Lattice executes the sensor handshake. It fuses the AESA radar returns with the infrared thermal data. It strips away the background noise. The AI classifies the anomalies. It identifies the acoustic signature of the two-stroke engines. It categorizes the threat as Group 3 unmanned aerial systems. The invisible swarm is now permanently illuminated on the digital battlespace. Condition 1 is achieved. Detection is absolute. Condition 2. The algorithmic triage. The swarm closes to 20 miles. The flight time to impact is roughly 10 minutes. Under legacy doctrine, alarms would sound. Human commanders would scramble to allocate interceptors. They would authorize the launch of multi-million-dollar Patriot missiles to break the swarm. They would fall directly into the adversary's economic trap. Lattice overrides this human instinct. It executes Condition 2, algorithmic triage. The AI calculates the cost-exchange ratio and the threat velocity in real time. It recognizes that these targets are subsonic and unarmored. Lattice places a hard digital lock on the Patriot missile batteries. It refuses to authorize a kinetic launch. It holds the heavy missiles in reserve for the anticipated secondary strike. Instead, Lattice networks 4 AMP-HEL striker vehicles positioned around the base perimeter. It divides the 36 targets among the 4 50-kilowatt lasers. It creates an optimized interlocking firing solution based on line of sight and atmospheric density. Target 1 through 9 is assigned to Battery Alpha, target 10 through 18 to Battery Bravo. Lattice calculates the exact intercept geometry for all 36 targets simultaneously. No human brain can compute that math. Condition 2 is achieved. The defense has bypassed the economic trap and optimized the battlefield. Condition 3. Thermal eradication at the speed of light. The drones cross the 5-mile lethal threshold. They are now within visual range. The drone cameras lock onto the base infrastructure. Lattice authorizes the engagement. Condition 3 begins. Battery Alpha's optical director slews to target 1. The tracking gimbal moves with violent mechanical precision. The laser does not simply paint the drone. Lattice utilizes advanced computer vision to identify the drone's center of gravity. It targets the specific compartment housing the lithium-ion batteries and the high-explosive payload. The 50-kilowatt laser fires. There is no recoil. There is no sound. A silent, concentrated beam of photons strikes the drone at 186,000 miles per second. The beam is focused to the size of a quarter. The physical reality of directed energy is brutal. The laser delivers intense, localized thermal energy. The carbon fiber casing of the drone heats to 800 degrees Celsius in 1.2 seconds. Let me repeat that. 800 degrees Celsius in 1.2 seconds. The structural integrity of the wing fails. The beam burns through the casing and ignites the lithium-ion cells. The battery enters a state of catastrophic thermal runaway. The drone detonates mid-air, vaporizing itself into a cloud of harmless burning debris. Condition 3 is achieved. The physical threat has been structurally disassembled by localized heat. Condition 4. The instantaneous magazine reset. In traditional warfare, launching a missile creates a mechanical deficit. You must wait for the launch tube to clear. You must wait for the next missile to spin up its internal gyroscopes. Condition 4 introduces the infinite magazine. The moment Lattice's optical sensors detect the thermal bloom of target 1 exploding, it instantly cuts the laser power. There is zero mechanical delay. The optical director snaps to target 2 in a fraction of a second. The diesel generator feeding the AMP-HEL maintains a constant flow of electrical current. Detect, illuminate, eradicate, reset. The 4 AMP-HEL batteries execute this loop with clinical, terrifying efficiency. The sky fills with secondary explosions. Lattice compensates for the smoke and debris of destroyed drones, seamlessly shifting target prioritization to maintain clear lines of sight. Within 90 seconds, the sky is clear. All 36 drones are destroyed. 0 kinetic interceptors were fired. The base's Patriot batteries remain fully loaded, untouched, and ready to intercept the adversary's heavier cruise missiles. The total cost of eliminating the 36 drone swarm was approximately $360 in diesel fuel. The adversary spent nearly $100,000 to achieve absolutely nothing. The mathematical equation of asymmetric warfare has been shattered. The play is over. The system holds. Battles are won by the infantry. Wars are won by logistics. But the survival of global superpowers is dictated entirely by industrial depth and engineering truth. For the last 20 years, we attempted to solve a new mathematical problem with an outdated formula. We believed that precision engineering meant building a flawless, $2 million missile to shoot down a cheap piece of flying plastic. We allowed adversaries to dictate the terms of engagement. We allowed them to bankrupt our magazines. The $600 million Joint Task Force 401 initiative is more than a hardware upgrade. It is a fundamental paradigm shift in the philosophy of defense. The integration of Anduril's Lattice network with high-power directed energy proves that American engineering can adapt to the economics of the modern battlefield. We are no longer bleeding our resources dry. We are stripping away the enemy's singular advantage. By utilizing artificial intelligence for perfect sensor fusion and lasers for infinite magazine depth, we restore the sanctity of our airspace. We preserve our critical kinetic assets for the existential threats that truly demand them. The math has been corrected. The shield is now cheaper than the sword. If this breakdown helped you understand the formula of the $600 million Anduril intercept, decoding the Joint Task Force 401 plan to kill drones with high-power lasers, subscribe and ring the bell to dissect more advanced weapon technologies and tactical wargames.